teach the tension force in the last video. In this video, we are going to talk in details about this force and we'll make some virtual lab uh, experiments showing the Hooke's law. So, as we said that we can calculate the tension force, the magnitude of the tension force using Hooke's law, which is tension equals to stiffness times the elongation. The elongation or compression, um, it's the difference between the initial length, which is the starting length, and the new length. Elongation is the difference, which means that it's the subtraction between the new length L1 minus the initial length, which is L0. So delta L equal L1 minus L0. If we elongated the spring more, we subtract from the initial length also, not from the previous length. So it's always L minus L0 and not L minus L2 minus L1 or L3 minus L2. It's always the subtraction from the initial length. If the spring is compressed, the equation will be L0 minus L since the initial length will be greater than the new length. When the spring is compressed, let's say its initial length was 10 centimeters. When we compress it, it will become, let's say, 5 centimeters. So the compression is 10 minus 5. We subtracted the initial length from the new length. So the elongation should always be a positive value. Okay. We can apply the Hooke's law in this virtual lab. We can see here the ruler. We'll measure the length of the spring, the initial length of the spring. Let's say it's about 30 centimeters. I'll hang 100 grams mass to this spring. Okay. I just increase the friction so the spring will stop. Okay, if we measure the new length of the spring, we'll notice that it's about 40 centimeters. So to calculate the 30, then it's 40. To calculate the elongation of the spring, we'll just subtract 40 minus 30, which is 10 centimeters. Now we have the elongation delta L. Of course, when we add a heavier object, which is 250 grams, of course, we'll notice that the spring will elongate more, and the new length is about 54 centimeters. Okay, so the elongation is 54 minus 30, which is about 24 centimeters. Okay, now we can apply Hooke's law to calculate the tension or the stiffness of the spring. Okay, um, let's uh, let's see this file. Okay, we can calculate we can measure the new length of the spring in 4 different readings. Okay, and calculate the elongation for these readings. Okay, then we can calculate the tension force. How can we calculate the tension force? Since we don't have the stiffness. Okay, according to equilibrium, according to the condition of equilibrium, the forces acting on the mass is the tension and the weight. These two forces are in equilibrium since the object is at rest, so it's in equilibrium. So tension is equal to weight. So we can calculate the tension from the weight. Weight equal mass times gravity. So now we have the tension. We have the tension and the elongation, delta L or X. We can simply use the Hooke's law and calculate the stiffness K equals T equal K delta L or the K equal T over delta L. Okay, thank you.